After learning the concept of triangle congruence and how to make a geometric proof in a two-column form, let us now apply them in constructing perpendicular lines and angle bisector. And let us also prove theorems related to the slopes of a parallel and perpendicular lines. In this video, we will also solve problems related to the slope of parallel and perpendicular lines and angle bisector. If you are new to this channel, kindly hit the subscribe button and the notification bell, and I promise that I will journey with you in learning math lessons and concepts in an easy way. Applying the triangle congruence in constructing perpendicular lines and angle bisector. These are our objectives. After watching this video, you will be able to apply triangle congruence to construct perpendicular lines and angle bisectors. Prove the slope of a parallel and perpendicular lines. And solve problems involving perpendicular lines and angle bisector. Now, let's recall that in graphing linear equation, we need at least 2 points. So suppose we have this point at the origin. This is point A. We have another point here, which is point B, and the coordinate is 4 and 3. If you connect these 2 points, so we have line AB. We also have another point, which is point C, whose coordinate is -2 and +2, and point D, whose coordinate is 2 and +5. So if you connect the 2 points, so this is line CD. So this line CD and line AB are called parallel lines. They are parallel because these two lines are coplanar and they do not intersect. Why two lines do not intersect? So let's illustrate this one using the concept of slope. And we all know that in finding the slope given the 2 points of a line, we have the formula slope is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. The slope of line AB, our y sub 2 would be 3 minus y sub 1, which is 0. Our x sub 2 is 4 minus 0. So the slope of line AB is 3 over 4. Now, if we will get the slope of line CD, our y sub 2 is 5 minus our y sub 1 is 2 all over 2 our x sub 2 minus x sub 1, which is -2. Simplify. So 5 minus 2 is 3. Then this is negative. So negative times negative becomes positive. So 2 plus 2 equals 4. The slope is 3 over 4. So as you can see, the slope of line AB and the slope of line CD, they are equal. So therefore, we can have a theorem that says if line AB is parallel to line CD, then we can say that their slope are equal. Let us remember that parallel lines have the same slope. Now, let's recall perpendicular lines. We all knew that perpendicular lines are two intersecting lines that forming a right angle. And right angle is an angle that measures exactly 90 degrees. We also knew that the angle is right angle if we can see a box at the vertex of the angle. So these three angles here illustrated are formed when these two lines intersect. Now, let's construct a perpendicular lines using a triangle congruence. We will illustrate this in the Cartesian plane. Suppose we have this triangle that one of its vertices lie at the origin, and we have this point here, and we call it as point N. In this case, we did not know what is the coordinate of this point. So since this is a triangle that lies in the Cartesian plane, so we call the distance from this point at the origin up to here as distance A. And from this point up to here, we will represent it as distance B. So therefore, the coordinates of point N is A, B. Now, in geometry, we have different transformations. And one of the transformations, we call it as rotation. Now, if we will rotate this triangle 90 degrees, so this would be the orientation of our triangle now. So we have this point, and this is point P. Now, as you can see, if this triangle is being rotated 90 degrees, this side now would be this side. So therefore, we can represent this distance also as A. And this distance from here is being rotated, and that is represented by B. So therefore, the coordinate of P which is located in the second quadrant, this is negative b comma p. So the x-coordinate is negative b, and the y-coordinate is positive a, since the point is at the second quadrant. And the coordinate of the vertex, we all knew that that is 0, 0. Suppose we will remove this side and this side. So what is left are these two sides, and we all know they are forming a right angle. Now let us determine the slope of these two perpendicular lines. They are perpendicular because a while ago we rotated the triangle 90 degrees. So the slope of the first line, which is mn, the formula for slope, so that is y sub 2 minus y sub 1, so that would be b minus y sub 1 is 0, all over x sub 2a minus 0. So the slope of this first line, mn, is b over a. Now the slope for the segment or line pm or mp would be a, our y sub 2 minus 0, then all over negative b minus 0. So simplify. So the slope of segment MP is a over negative b. Now, what is the relationship between the slopes of these two perpendicular lines? Of course, they are not equal, but as you can see, they are being switched. So the numerator becomes the denominator, and the denominator becomes the numerator. So that is the relationship. By switching the numerator and the denominator, we call it as reciprocal. Their relationships is called negative reciprocal. If we will multiply the slopes, because reciprocal, if we will multiply them, the product is 1. Now, negative reciprocal, if you multiply the two slopes, their product is equal to negative 1. So if this is b over a, the slope of the first line, times the slope of the second line, so strike this out because they are equal, but this is negative 1. So this is positive 1. So positive 1 all over negative 1 is negative 1. So therefore, we can have another theorem that states if two lines are perpendicular, then the product of their slopes is equal to negative 1. Or, in layman's terms, the slopes of the two perpendicular lines are negative reciprocal to each other. Now, let's verify their slopes, supposing that we indicated the units in the Cartesian plane. So the coordinate of point N is 4 and 5. The coordinate of point P, negative 5 and positive 4. The slope of Mn would be 5 minus 0 over 4 minus 0, and the slope is 5 over 4. Then the slope of MP is 4 minus 0 all over negative 5 minus 0, and that is 4 over negative 5 or negative 4 over 5. If you multiply 5 over 4 by 4 over negative 5, their product is equal to negative 1. So indeed, this theorem is true, that the product of their slopes is equal to negative 1. Let's also recall an angle bisector. So BED is congruent to angle DEC. So therefore, this ray AD, is called the angle bisector. Angle bisector again, it is a ray or a segment that divides the angle into two congruent angles. Now, let's construct and prove an angle bisector using triangle congruence. So, we'll illustrate this one through this figure. This is an angle formed by two rays sharing common endpoint, and the vertex is point A. Now, our objective is to find point from this ray and this ray which are equidistant. So to get that point, we will make use of our compass. So if we don't have a compass, we will draw a circle such that this point, the vertex, would be the center of this circle. So by definition, the radii of the circle is equal. So therefore, this point here, point B, is equal to the point here, which is point C, because these two segments, AB and AC, are the radii of this circle A. Next thing that we're going to do, we will make a circle whose center is point B, such that the radius of this circle point B is equal to the radius of the first circle A. Let's also draw another circle whose center is point C. The point where the two circles intersect, together with the vertex of the angle, connect them or draw a line or a ray, and this is now a segment that somehow would represent the angle bisector. But how do we know that it is truly an angle bisector? This can be only an angle bisector if we can prove that this angle and this angle are equal. Because angle bisector by definition, it divides this angle into two equal parts. Now from this illustration, as you can see, connecting point A, this radius, and this radius, so we form triangle ABD. And also AC and CD. Our objective now is to prove that
These angles
are equal so that we can conclude that indeed this ray BD or ray AD is the angle bisector of angle BAC. Now, from this illustration, we can say that A, B, C are the centers of the three circles, circle A, circle B, and circle C, respectively. Our task is to prove that AD is the bisector of angle BAC. Now, again, we will do the two-column proof. So, the first would be the given. So, of course, the reason is given. Out from this statement, we can say that this segment is equal to this segment, and this segment. So, these four segments are congruent by the definition of the radius of the circle. Now, thirdly, as you can see, this segment, AD, is common to these two triangles. So, by reflexive property, we can establish that this segment is equal to itself. So, we can now conclude that triangle ABD is congruent to triangle ACD by SSS postulates, or the side-side-side postulates. Since we already established that these two triangles are congruent, so this angle is corresponding angle of this angle. Therefore, we can have statement number 5 that angle BAD is congruent to angle CAD. The reason is the CPCTC theorem. The corresponding parts of congruent triangles are congruent. Now, since we already established in statement number 5 that these two angles are congruent, now we can already prove our task that AD is the bisector of angle BAC because of the definition of angle bisector. Because we proved in statement number 5 that this segment divides this angle BAC into two equal angles. Let's apply our understanding of the lesson in solving the following problems. Example number 1, find the slope of the line that are parallel and perpendicular to the line that passes points 1 and 2 and negative 3 and 5. So first, to determine the line that is parallel or perpendicular to the line that passes through this point, we need to know what is the slope of that line. So to find the slope, we will use the slope formula. So our y sub 2 is 5 minus y sub 1, 2, all over x sub 2, negative 3 minus 1. Simplify. So 5 minus 2 is 3. Negative 3 minus 1 is negative 4. So the slope of this line that passes through these points is negative 3 over 4. So the slope of the line which is parallel to the line that passes through these 2 points have the same slope. So the slope is negative 3 and 4. The slope of the line perpendicular to this line, so we just get the negative reciprocal of this slope. So since this is negative, so its reciprocal is 4 over 3. Example number 2, find the slope of the line that are parallel and perpendicular to the line 2x minus 3y minus 12 equals 0. So in this case, the line is given in general form. We need to rewrite the equation into the slope-intercept form, which is y equals mx plus b, so that we will be able to determine what is the slope of this line. The y form or the slope-intercept form of this equation, so this would be negative 3y. By addition property, transpose 2x to the right side, so that would be negative 2x, then plus 12. Divide both sides by negative 3 to solve for y. So our y is negative 2 divided by negative 3 is positive 2 over 3x. Then positive 12 divided by negative 3 is negative 4. So in this case, the slope of that line is 2 over 3. Now what is the slope of the parallel line? So they have the same slope. The slope of the perpendicular line, the negative reciprocal of this slope. So that is negative 3 over 2. Example number 3. Find the equation of the line that is parallel to the line y equals 5x minus 2 and it passes through point 3 and 4. So in this kind of problem, we will be able to recall our lesson about writing an equation of the line. So we have different forms. We have the slope-intercept form, we have the point-slope form, we have the two-point form. In finding the equation of the line that is parallel to this line, we need to know first what is the slope of this line. So the slope of line y equals 5x minus 2 would be 5. So the slope, using the slope-intercept form, is just the coefficient of x, provided the coefficient of y is already positive 1. We will now write the equation of the line that passes through this point given that the slope is 5. So take note, parallel lines, they have the same slope. So the point slope form formula is y minus y sub 1 equals the slope times x minus x sub 1. So since it passes through this point, so this would be our x sub 1 and this would be our y sub 1. So substitute to the given formula. So we have y minus our y sub 1, 4, is equal to the slope, which is 5, since they are parallel, times x minus our x sub 1, 3. Simplify. So y minus 4 equals 5 times x, 5x, 5 times 3 is negative 15. Further simplification, so this would be y, copy 5x, then negative 15 transpose is positive 4. So therefore, the equation of the line is y equals 5x minus 11. So this is the equation of the line that is parallel to this line. To illustrate, so we'll show it in the graph. So the black one is the graph of 5x minus 2, while the blue one is 5x minus 11. So as you can see, these two lines are parallel. Example number 4. What is the equation of the line perpendicular to the same line in the example number 3 and it passes on the same point? We already knew that the slope of this line is 5. So since we are looking for the line that is perpendicular to this line, so we will take the slope which is the negative reciprocal to this slope. So the negative reciprocal of 5 is negative 1 over 5. Using the point slope form formula, substitute y minus 4, our y sub 1, is equal to the slope, which is negative 1 over 5, times x, our x sub 1 is 3. We'll get rid of the fraction by multiplying the whole equation by the LCD, and which is 5. So this is y minus 4 times 5. Now, if this expression multiplied by 5, so the denominator be cancelled out, so what is left is just negative 1 times x minus 3. So, further simplification, 5 times y is 5y, 5 times negative 4 is negative 20, negative 1 times x is negative x, then negative 1 times negative 3 is positive 3. Further simplification, by addition property of equality, transpose negative x to the left, that is positive x. We just copy positive y, then copy positive 3, then transpose negative 20 to the right, it turns to positive 20. Simplify, so that is x plus 5y equals 23. So this is now the equation of the line perpendicular to this line that passes through point 3 and 4. Now let us illustrate. As you can see, the first line is y equals 5x minus 2, while the other line, this is perpendicular line to this line, the equation is x plus 5y equals 23. Let's verify if this line perpendicular to this line really passes to point 3 and 4. Where is 3 and 4? So 3, 4. So it is here. Indeed, that the line x plus 5y equals 23 is perpendicular to this line and it passes through point 3 and 4. Example number 5. Let's have this illustration. So this is SUT and this segment PU or UP is the angle bisector of SUT. The measure of this angle SUT is 42. Now what is asked is the measure of angle 2. To solve for the measure of angle 2, we all knew its relationship that these two angles are equal and the given is the overall angle. So therefore, the measure of angle 2 is just 1/2 of the measure of angle SUT. If the measure of angle SUT is 42, it's 1/2, divide it by 2, so the measure of angle 2 is 21 degrees. Same is true with the measure of angle 1. Example number 6. PX is the bisector of angle YXZ, And if the measure of angle 2 is equal to 4x plus 5 and the measure of angle 1 is 5x minus 2, now find the value of x and the measure of each angle. Based from the given, we can say that angle 1 and angle 2 are equal because peak x is the bisector of angle xyz. So in this case, since they are equal and we represent the measure of angle 1 as 5x minus 2, so we just substitute. The measure of angle 2 is represented by an expression 4x plus 5, substitute. By addition property of equality, group the like terms. So we have 5x minus 4x and it is equal to 5 positive 2. Simplify, so 5x minus 4x, so that is 1x or x. Then 5 plus 2 is 7. So the value of x is equal to 7. Now another question is the measure of each angle. So if x is 7, what is the measure of angle 1 and measure of angle 2? So the measure of angle 1 is 5x minus 2. So if x is 7, substitute. So 5 times 7 is 35. Then minus 2 is 33. So measure of angle 1 is 33 and they are equal to measure of angle 2. So our angle 2 is also 33 degrees. Now after learning the lesson for today, now is your time to measure your understanding about the lesson. Okay, write your answer in the comment section below. Question number 1, find the slope of the line that are parallel and perpendicular to line that passes through points -2 and 5 and -3 and 1. Find the slope of the line that are parallel and perpendicular to the line 5x plus 2y equals 8. Question number 3, find the equation of the line that is parallel to the line y equals 1/3 x plus 2 and it passes through the origin. Problem number 4, find the equation of the line that is perpendicular to the line y equals -3x plus 5 and it passes through point 1 and 0. Problem number 5 is segment PB is the bisector of angle CBD. If the measure of angle 2 is 7x plus 2 and the measure of angle 1 is 9x minus 5, so find the value of x and the measure of each angle. So using this illustration.
Thank you for finishing this video. If you learned something new today, kindly smash that like button. And in the comment section, kindly send me your thoughts about this video. Please don't forget to subscribe and share this video so that I will be able to continue to journey with you in learning math lessons in an easy way. See you in our next video. Thank you for watching.